Hello everyone, I hope you're all doing well today. Our topic for today's lesson is quadratic formula. Our essential question is how can we use quadratic formula to find solutions? We have learned before that if we have a quadratic function, in order to find the solution of that quadratic function, we need to factor the function first. Then we set each factor equal to 0 and we are able to find the solutions from there. But what if our function is not factorable? In that case, we need to use the quadratic formula. But before using the quadratic formula and learning about that, we need to make sure that our quadratic equation is in standard form. This is the standard form of a quadratic equation. Descending order, starting from ax squared, then bx, and then the constant term. And make sure that the other side of the equation is equal to 0. Then we are able to use the quadratic formula. What is quadratic formula? It looks like this. X is equal to negative b plus and minus square root of b squared minus 4ac over 2a. So here, the terms that you see here, here, b squared, 4ac, and a that you see in the bottom, they're all taken from the standard form of the equation. So your b value that you see here is the coefficient of the second term. And this b is also the same thing. This a that you see here is the coefficient of x squared. C is the last term, which is our constant number. So we just need to replace these values from our equation into this formula, and then we are able to find a solution. We can use the discriminant in order to predict what kind of solutions and how many solutions we're going to have in our quadratic function. So what is discriminant? Discriminant is just this part, which is under the square root here, and it's just b squared minus 4ac. So if you have a quadratic function like this one, a squared plus bx plus c equal to 0, you find b squared minus 4ac using all these coefficients. And according to the table that we have here, if that discriminant is a number which is greater than 0, then we will have two real solutions. If the discriminant is equal to 0, we will have only one real solution. And if it's a number less than 0, that means it's a negative number, then we will have two complex solutions. Okay, now let's work on this example. X squared plus 10x plus 2. We want to find the solution of this function. That means we want to know for what x values this function is equal to 0. First of all, is this function factorable or not? If we notice, we'll see that we cannot find two numbers that if you multiply them, you get 2, and if you add them, you get 10. So that means we are not able to easily factor this function. So we're going to use the quadratic formula. Before using the quadratic formula, we need to make sure that this is in standard form, which already is in standard form because it starts from x squared, then x, and then the constant number. So now I can identify my a, b, and c values. A is the coefficient of x squared, so it's 1 here. If we don't have any number behind the variable, the coefficient is 1, so this is 1. B is the coefficient of x, which is 10 in this case. And c is the constant number, which is 2. Okay, so I can use my discriminant here to predict what kind of solutions and how many solutions I have, because if the discriminant is a positive number, then we have two real solutions. If it's 0, one real solution, and if it's a negative number, then we have two complex solutions. So let's see what is our discriminant. The discriminant can be found using this formula, b squared minus 4 times a times c. So what is y b squared? It's 10 squared, which is 100, minus 4 times a, which is 1, times c, which is 2. I can put this in a parenthesis to make sure I don't subtract 4 by 100 first, then multiply by that. According to PEMDAS, we need to multiply these first, then subtract the answer from 100. Okay, so this is 100 minus 4 times 1 times 2 is 8. It's 92. As you see, our discriminant is a number which is positive. It's greater than 0. That means we are going to have two real solutions. Okay. Now, we're going to use the quadratic formula to find the root. And here's our quadratic formula. I'm just going to replace all the values that I have for a, b, and c into this function, this equation, and find my roots from here. So negative b means negative 10. B was 10. Plus and minus square root of, we already found this part, which was equal to 92. So I'm going to replace 92 here, and then 2 times 1, because a value is 1, which is equal to 2. Now basically I have found my solutions. I just need to simplify this. Let's see first of all if we can simplify square root of 92. So 92 can be divided by 2, and it's equal to 46. 46 also can be divided by 2, and it's going to be equal to 23 times 2. As you see, 23 is a prime number, and we cannot factor this anymore. So 92 is equal to 2 times 2 times 23. Now, what is square root of 92? Because I have a perfect square here, I can move this out of this square root and write it as just 1, 2. You're moving this out. It's going to be just 1, 2, because square root of 2 by 2 is 2 times 23. So 90 square root of 92 can be simplified as this number. So I'm going to write that negative 10 plus and minus 2 square root of 23 over 2. Now I can simplify this one more time by dividing all these by 2. Like, factor the 2 from the top, it will be negative 2, or I can say let's not factor the negative. Let's just factor the 2 out, and then we are going to have 2 times negative 5 plus and minus, so this 2 will go away, 2 square root of 23, and then the 2 is the bottom. Now I can simplify top and the bottom, and I'm left with just negative 5 plus and minus square root of 23. So this will be the answer of the roots. Now we just need to simplify this one more time by dividing all these numbers by 2. Like 10 divided by 2 is 5, and I keep the negative. Then I have plus and minus. 2 divided by 2 is 1, so I don't have to write that. Is 23, and the bottom also 2 divided by 2 is 1, and again I don't have to write that. So this is basically my answer. The solutions are, one of them is negative 5 plus square root of 23, and the other one is negative 5 minus square root of 23. For next example, we have 2x squared minus 3 equal to x. So first of all, as we said, our equation should be in standard form. So let's put this in standard form. I know that the right side of my equation should be 0. So I'm going to put that in order in this form. Negative 3 equal to x. So I subtract x from both sides. So in this way, I have 2x squared minus 3 minus x equal to 0. The next thing that I need to do is to just switch these two terms, because our standard form is like ax squared plus bx plus c. So this x term should be in the middle. So I just switch these two and my equation will be 2x squared minus x minus 3 equal to 0. Now we need to find a, b, and c. As we know, a value is the coefficient of x squared, which is 2. B is coefficient of x, negative 1 in this case, because we have negative x, that means it was negative 1 times x. So it's negative 1, and our c value is negative 3. So this is negative 3. Now we need to find a discriminant. B squared minus 4ac. That's our discriminant formula. B squared is negative 1 squared minus 4 times a, which is 2, times negative 3. I'm going to put the negative 3 here in parentheses because like we don't want two signs beside each other, like times and a negative. We don't want them to be stuck together, so we separate them with a parenthesis. Okay, now let's calculate this. Negative 1 squared is equal to 1 because it's negative 1 times negative 1. So it's going to be negative times negative, positive. Notice that here, if I want to use my calculator, I have to put this in parentheses. Otherwise, the answer that I'm going to get will be negative 1, because the calculator is not smart enough to understand that if you say negative 1 squared, it means negative 1 times negative 1. The calculator thinks that you are asking it to find, I'm sorry, this is the calculator assumes that you're asking it to find negative 1 times 1. So that's why if you don't put this in parentheses, you're going to have the wrong answer, which is negative 1. That's wrong. That's not what we want. We need negative 1 to the power of 2. Anyway, so if I put this in parentheses, negative 1 squared will be 1. And then here I have 4 times 2, 8, times negative 3 will be negative 24. And we had another negative behind all these. So it's negative times negative 24 is plus 24. So the answer is 25. And as you see, our discriminant is a number which is positive, it's greater than 0. That means we will have two real solutions. Okay. Next, we're going to use the quadratic formula to find. Okay, so here's our quadratic formula, and we're just going to replace a, b, and c values into the formula. Negative b is negative times b is negative 1. So it's going to be like this, negative times negative 1. Plus and minus square root of b squared is negative 1 squared minus 4 times 2 times negative 3, which we already calculated that one as 25. I'm just going to write that to make sure you know what is happening here. So this is 2 times a value is 2, so I replace that here. Okay, so now let's just calculate all these. Negative times negative 1 will be positive 1. Plus and minus, the discriminant was already 25 found, so it's square root of 25 over 2 times 2 is 4. And we already know that square root of 25 is 5. So our x value is going to be 1 plus and minus 5 over 4. So let's just simplify them again. So one of the answers is 1 plus 5 over 4, which will be 6 over 4. Just at the top, 6 over 4, and you can simplify that. 6 divided by 2 is 3, 4 divided by 2 is 2. So 3 over 2 is one of my answers. And the other one is 1 minus 5 divided by 4. 1 minus 5 is negative 4. Divide by 4 will be negative 1. So our answers are 2 over 3 and negative 1. Now let's work on example 3. X squared minus 6x plus 9 is equal to 0. This quadratic function is in standard form, so we're good for that. Now we just need to find a, b, and c. A is the coefficient of x squared, which is 1. B is coefficient of x, which is negative 6 here, and c is the constant term, which is 9. Now the discriminant is b squared minus 4 times a times c. Okay, let's start with b. B is negative 6. Once again, I'm going to put this inside the parentheses and raise it to the power of 2, especially if you're using your calculator. Make sure you put that in the parentheses. Then I'm going to write minus, let's put this in parentheses again, 4 times a is 1 and c is 9. Okay, negative 6 squared is negative 6 times negative 6, which is positive 36. 4 times 9 times 1 is again 36. So this is minus 36, and it's equal to 0. And we said that if our discriminant is equal to 0, that means we are going to have only one real solution. Now let's find that solution. Once again, I need to use my quadratic formula. Here's our formula. Let's start with negative b. So I'm going to write negative times b is negative 6. And plus and minus our discriminant, which we already solved that, and it was equal to 0. So I just write that here under the square root. And then in the bottom we have 2 times a, which is 1. So let's simplify that. First of all, if I have square root of 0, square root of 0 is always equal to 0. So basically this is nothing, it's just 0. So what I'm left with here is just negative times negative 6, which is positive 6. And after that, because it's plus and minus 0, it's not going to change my answer, so I'm not going to write even that part. And then let's just go to the bottom of this fraction. 2 times 1 is 2, so it's equal to 3. So that's why if our discriminant is 0, we're going to have only one solution, and here in this case it's 3. Next example, we have x squared minus 2x minus 12. First of all, we need to put this in standard form. So I'm going to add 12 to both sides because I know that the right side should be equal to 0. So I'm going to cancel the negative 12 by adding 12 to both sides. So this is going to be x squared minus 2x plus 12 equal to 0. Okay, so let's go find a, b, and c. A is the coefficient of x squared, which is 1 here. B is coefficient of x, negative 2. And c is the constant, it's 12. Now let's go and find the discriminant. Let's see what happens there. B squared minus 4 times a times c. B squared is negative 2 squared minus 4 times a, which is 1, times C, which is 12. Okay, negative 2 squared will be negative 2 times negative 2, it's 4. And then 4 times 1 times 42 is 48. So it's 4 minus 48. So the answer is negative 44. As you see, this time our discriminant is a negative number. It's negative, it's less than 0. So I can say I'm going to have two complex solutions. Now let's see how we can find complex solutions. In order to find the solutions or the roots using the quadratic formula, I'm going to use the formula and replace the values. Negative b, it will be negative times negative 2 plus and minus square root of negative 44. That's what we already found for our discriminant. So it's negative 44 here, divided by 2 times a, which is 1. So 2 times 1 is 2. So I can write this as negative times negative is positive 2 plus and minus square root of negative 44 divided by 2. Now we need to simplify this, but before that, let's see what is the square root of negative 44. Okay, we have learned before that if we have square root of a number, that number on the radical should be a positive number. And if it's negative, we say that there is no solution in real numbers. But guess what? There is a solution in imaginary numbers. What are imaginary numbers? We have a number called that I. This I is equal to square root of negative 1. We call this an imaginary number because it doesn't exist in real world. Okay, so I is equal to radical negative 1 or square root of negative 1. Now let's see what is negative 44. First of all, negative 44 is negative 1 times 4 times 11. Now what is square root of negative 1? That's square root of all these. Now I can separate all these numbers with their square roots. So it's going to be square root of negative 1 times square root of 4 times square root of 11. What is square root of negative 1? We just found that it was equal to I. So instead of square root of negative 1, I'm going to write I. Instead of square root of 4, well, of course I can write 2. I'm going to write that in front of I because we're just used to write the coefficients in front of the letters. And then we have square root of 11. So square root of negative 44 is equal to 2i square root of 11. This is called an imaginary number because it has I in itself. Okay, so I'm going to write this as 2 plus and minus 2i square root of 11 over 2. Now I can simplify all the 2's. 2 divided by 2, 1, divided by 2, 1, and this one divided by 2 is 1. So our x is 1 plus I radical 11. That's one of the roots. And the other one is 1 minus I radical 11. So these are our two complex solutions. Why do I call this complex solution? Because it's the complex of 1 plus like a real number plus an imaginary number. That's why we call them complex solutions. The second part of our lesson today is solving with complex numbers. So we want to learn how can we find the complex solutions of a quadratic function. Let's learn that by trying these examples. Here we have x squared plus 4 equal to 0. Because it's just a binomial, I can easily solve this by solving for x. That means just putting x on one side and everything else on the other side, and then we can solve this for x. So what I'm going to do here is to subtract 4. I'm trying to put x on one side by itself. So these two will cancel, and this is x squared equal to negative 4. Now, in order to solve for x, I need to get rid of the power of 2. So I take the square root of both sides. And now here, this square root and this power cancel each other. And on the left side, I have x. And on the right side, I have negative 4. As I told you before, if you have a square root and the number under square root is a negative number, that means we don't have a real solution, but we will have imaginary solution or complex solution. So now let's see how we can find the complex solution of this one, or imaginary solution. So we know that, I'm going to write that here, negative 4 is negative 1 times 4. So square root of negative 4 is square root of negative 1 times 4. So this is again square root of negative 1 times square root of 4. Square root of negative 1, we told you before that it's equal to I. So I'm going to write I here. Now, what is square root of 4? That's plus and minus 2. Okay, I can write the 2. Let's write the 2 in front of I. So instead of writing plus and minus I2, I write that plus and minus 2I, because we're just used to write the numbers in front of the letters. Okay, so it's plus and minus 2I. So here, once again, in order to solve this, I'm going to write, instead of this negative, I'm going to move the negative to the outside based on what I just learned. Move the negative to the outside and write that as I. That's what we just did here. And then I have square root of 4, which is plus and minus 2. So I'm going to write here as plus and minus 2I. So plus and minus 2I are the answers of this function. Now let's work on the other one. Again, here I have x squared minus 11 minus 47. I have one term with the variable x squared, and the other two terms are constant numbers. So what I'm going to do here is to add 11, because again my goal is to have the x on one side by itself. So add 11, and here I'm going to have 2x squared equal to negative 36. Okay, then divide both sides by 2. These two will cancel, and x is equal to negative 18. I'm sorry, x squared is equal to negative 18. Now I need to get rid of the square here, so I take the square root of both sides. These two cancel each other, the square root and the square cancel each other, and I will have x is equal to square root of negative 18. Based on I just said, I can move this negative outside and write it as I. Okay, so I'm going to write the I for now. Now let's see what is square root of 18. Okay, so this is basically I times square root of 18. I need to find what is square root of 18. Simplify that. So let's go here. 18 is 2 times 9. And we know that 9 is 3 times 3. So if I want to find square root of 18, that's square root of 2 times 3 times 3. And here we have a pair, so I can remove them here and write as just 1 3 outside, and write it as 3 square root of 2. But notice that this is plus and minus square root of 2 times 3. So this is going to be plus and minus 2i. Oh, I'm sorry. Um, it's basically plus and minus 3i square root of 2. Now let's practice more. We have 4x squared plus 20 equal to 0. So we want to solve for x. So my goal is to have the x by itself on one side. So subtract 20 from both sides. These two cancel. And then we'll have 4x squared equal to negative 20. Now I can divide both sides by 4. So it will be x squared equal to negative 20 divided by 4 is negative 5. Now I'm going to take the square root of both sides. So the square root and the square cancel each other, and I have x equal to square root of negative 5. Because I have a negative inside the radical, I'm going to move that outside to the outside and write that as an I. So I'm going to have I radical 5, and because 5 is not a perfect square, I cannot simplify this more. I will just make sure to write plus and minus. And I'm going to explain to you why we put plus and minus. Let me explain to you using this example. Let's say we have x squared equal to 4, and I want to solve this. And so I just take the square root of both sides, and then I say x is equal to positive and minus 2. Why do I write positive and minus 2? Because if in the original equation, that is x squared equal to 4, if I replace x by 2, this is going to be 2 squared equal to 4. Yes, 2 squared is equal to 4. But on the other hand, negative 2 is also another solution, because negative 2 squared is also negative 2, negative 2 times negative 2, which is 4. So basically we have two solutions. Both of these two numbers, positive 2 and negative 2, raised to the power of 2, will be the solution of this equation. So the same is for all these equations that we just solved. If we take the square root of something, and then the answer will be plus and minus of the answer. Okay, so let's go to next example. 3x squared minus 7 equal to negative 31. Once again, because we don't have the x value here, like the x term here, we only have x squared and the constant term, so we don't use the quadratic formula. We're just going to solve by x by putting x on one side by itself. So I'm going to add 7 to both sides. This will be 3x squared equal to negative 37 plus 7 will be negative 24. Divide both sides by 3. And x squared equal to negative 8. So take the square root of both sides. And from here, x will be, first of all, move the 8 to the outside, so it will be I. And then I need to find the square root of 8. What is square root of 8? Let's see. 8 is 2 times 4. And 4 is 2 times 2. So square root of 8 will be square root of 2 times 2 times 2. And I have one pair here. I can move it to the outside as just 1, 2. So this is 2 square root of 2. Okay, so my answer will be plus and minus. I'm going to write the 2 in the front. Plus and minus 2i radical 2. Okay, in the next part of our lesson, we're going to learn how to remove the imaginary number from each denominator. First of all, this is called rationalizing. And then we want to know why would we want to remove the imaginary number from each denominator. Let me give you an example. When I give you 4 divided by 2, like this fraction, which is 4 over 2, it's easy to simplify this, yes? So just 4 divided by 2 is 2, easy, yes? But what if I give you 4 divided by I? What does that mean? We know that I is equal to radical negative 1. So this means 4 divided by radical negative 1. Well, this is even harder. How do I divide 4 by radical negative 1? So let's see how we can make this denominator easier and simpler. Because if we have a denominator which is the okay, in the second part of our lesson, we're going to learn how to remove the imaginary number from each denominator. This is called rationalizing. So first of all, let's see why would we need to learn to remove the imaginary number from the denominator. Let me give you an example. Let's say we have 4 over 2 as a fraction. Well, this fraction is easy to simplify. Just simply divide 4 by 2 and it's equal to 2. Yes. But what if I have 4 divided by I? What is that? We know that I is equal to radical negative 1. So this is basically 4 divided by radical negative 1. And now this is even harder to understand and harder to divide. What is 4 divided by radical negative 1? So our goal is to make the denominator more simple as possible. So we don't have something like a radical in the denominator. It's easier to have something like an integer in the denominator. So that's why we want to rationalize our fractions that have I in the denominator. So let's see how do we do that. Another example, if I have radical 2, I know that if I multiply that by radical 2, this will be square root of 2 times 2. And then because I have a per here as a perfect square, then this can be simplified as just 2. So if I multiply a radical by itself, I can get rid of the radical, and then I have just 1, 2. So the same is here. If I have radical negative 1, I multiply it by itself, then I will get rid of the radical, and it's equal to negative 1. Okay, so we're going to use the same trick. In order to get rid of the I in the denominator, which is radical negative 1, I need to multiply that by radical negative 1. Or basically, if I have 4 over I multiply the denominator by I to get rid of that I in the denominator. But here's the thing. If I multiply the denominator by something, I have to do the same thing to the top as well. Otherwise, I'm not going to have something equal to the first fraction that I had. So whatever I do to the bottom, I need to do the same thing to the top as well. So basically, in order to rationalize a, a fraction which has imaginary number in the denominator, I just need to multiply both top and the bottom by I. Like in this case, that's what I do. So 2 times I is 2I. And in the denominator I have 5I times I. And what is I times I? We know that I is radical negative 1, so it's I here times I, and we know that that's equal to negative 1, so it's just negative 1. So I times I is negative 1, or I can also say I squared is equal to negative 1. So the denominator is 5 times negative 1, which is 5I. So that's how we remove the imaginary number from the denominator. Okay, now let's work on the second example. We have 3 over 2 minus I. Again, we have an I in the denominator, and we want to get rid of this I in the denominator. But in this case, we don't have just one I here. We have 2 minus I. This is a complex number. That means we have an integer and added or subtracted to an imaginary number. So in order to get rid of the I in the denominator, when we have a complex number, we need to multiply both top and the bottom by conjugate of the denominator. What is conjugate of denominator? Like if I have 2 minus I as a complex number, conjugate of that is going to be 2 plus I. So you just need to change the sign that you have between the integer and the imaginary number. So if it's negative, then you change it to positive. Okay, so I multiply both top and the bottom by conjugate 2 plus I and 2 plus I. So to multiply the top by 2 plus I, like 3 times 2 plus I can just simply distribute the 3. So it will be 2 times 3, which is 6 plus 3 times I, which is 3I. And to multiply the bottom, again, I can use the distribution or the FOILing method to multiply them and find the answer, or you can also use your calculator, which is going to be faster and easier. So to multiply 2 minus I times 2 plus I, you're going to write 2 minus, where is the I? It's located here. So I do second this point, that gives me I, okay? And then I'm going to put the parenthesis behind that. So 2 minus I times 2 plus I, and the answer is 2 minus 4I. So it's 2 minus 4I. Okay, now let's work on the next example. Here we have 3 over 2 minus I. So we want to get rid of the I in the denominator, but the difference between this one and the previous problem is that we have a complex number. That means we have an integer, then we have plus or minus an imaginary number. This is called a complex number. So in order to get rid of the I in the denominator for a complex number, we need to multiply that by the conjugate number of this complex number. What is conjugate number? For example, if I have 2 minus I, the conjugate number of 2 minus I will be 2 plus I. So just simply change the sign of change the sign that is between the integer number and the imaginary number. So if this is negative, make it positive. If it's positive, make it negative. So these two are conjugate of each other. If you don't know how to find the conjugate of a number, you can use your calculator. So for example, I have 2 minus I, and I want to find the conjugate of that. So just simply go to math, and then here we have complex. So we go to the right side on the complex, and the first one gives you conjugate. So enter, and here I'm going to write 2 minus I. In order to write the I go to second, and here we see the decimal point. On top of that, we have I. So just second and point, you will get 2 minus I. Now, what is conjugate of 2 minus I? Is equal to, okay, let's work on this example. 3 over 2 minus I. In this case, again, we have an I in the denominator, and we want to get rid of that. We want to remove the imaginary number of I from the denominator. But the difference between this one and the previous one is that we have a complex number, like an integer plus or minus an imaginary number. We call that a complex number. To get rid of the I in the complex number, we need to multiply that number by its conjugate. What is the conjugate number here? If you have 2 minus I, the conjugate number of this is 2 plus I. So just change the sign that you have between this number and the I. If it's negative, now change it to positive. Or if it's positive, change it to negative. So now in order to get rid of this in the denominator, I need to multiply both top and the bottom by 2 plus I. Okay, so you can do all this by hand, like 3 times 2 plus I, just distribute that, it will be 3 times 2 is 6, 3 times I is 3I, and for the denominator, again, do the same thing, just do the foiling and like multiply 2 by 2, 2 by I, and negative I by 2, I by negative I. Okay, so 2 by 2 is 4, 2 by I is 2I, negative 2 by I is negative 2I, and negative I by I is negative I times I will be negative I squared, and we learned that I squared is negative 1, so it's negative times negative 1, which is 1. Okay, so it's basically plus, I'm going to write that as negative I squared first, negative I squared, and so the top is 6 plus 3I, the bottom 2I and negative 2I cancel each other, and here I have 4 minus I squared, which we said negative I squared will be 1, so it's 4 plus 1, which is 5. So that's the answer. You can also use your calculator to find both the conjugate and also to multiply the number by the conjugate. Okay, so let me show that to you, how you use your calculator for that. Okay, so first of all, let's say I have 2 minus I as a complex number. How do I show that on my calculator? I'm just going to write 2 minus, how do I find the I? Here. You see the point for decimal. You go second, and this point that gives you the I. So 2 minus I. This is a complex number. And like if you don't know how to find the conjugate number of a complex number, this is what you need to do. You go to math, and then to the right side over here that has complex. Now number 1 gives you conjugate. So I just enter. I want to know what is conjugate of 2 minus I. So I'm going to write 2 minus second point. What is conjugate of 2 minus I? It's 2 plus I. Okay. Now I just simply multiply these two. 2 minus I multiply by 2 plus I, and that's going to give us 5, the same thing that we found here. So you can use your calculator to find these, or just like what I did here, do all this by hand. Okay, now let's do this example. 5 plus 2I over 1 minus 3I. So again, we just want to get rid of the I in the denominator, and it's okay if we have the I on a numerator. We just want to get rid of it in the denominator. So to get rid of that, I need to multiply this by conjugate of the denominator, which is 1 plus 3I. So I need to multiply both top and the bottom by 1 plus 3i. And now I'm just going to use my calculator to find that. So what is 1 minus 3i times 1 plus 3i is equal to 10. So the denominator here will be 10. Then we need to multiply 5 plus 2i times 1 plus 3i. So 5 plus 2i times 1 plus 3i. And that's equal to negative 1 plus 17i. Okay, so it's negative 1 plus 17i. And notice here we still have the I in the top, and it's okay. We just wanted to get rid of the I in the denominator, and we did it. The next two examples, we're just going to review how we rationalize the denominators when we had a radical in the denominator. Again, the same story, we don't like the radical in the denominator and we want to get rid of that. If I have something like this, 2 over 5 radical 3, I just need to multiply both top and the bottom by radical 3. So I multiply that by radical 3 over radical 3. So now multiply top by top, so it will be 2 radical 3, and multiply bottom by bottom, 5 times radical 3 times radical 3. So we know that radical 3 times radical 3, then the radicals will go away and I will have only a 3 left here. So this is 5 times 3. So the fraction is going to look like 2 radical 3 over 15. 5 times 3 is 15. Okay. Now let's do this example. Again, here I want to get rid of the radical in the denominator, but I have like 2 minus radical 5. So in this case, I need to multiply that by conjugate of this number, which is, if this is 2 radical negative 5, 2 minus radical 5, the conjugate will be 2 plus radical 5. So you multiply both top and the bottom by 2 plus radical 5. The top is going to be easy for us to multiply. So just 3 by 2 is 6, and 3 by radical 5 will be 3 radical 5. Okay, and then the bottom, once again, you can either use it by hand, like just do the foiling and multiply them, or just use your calculator. So I'm going to use my calculator. 2 minus square root of 5. Let's put the parentheses outside, and multiply by 2 plus square root of 5. Okay, now this will be equal to negative 1. So the bottom is negative 1, and now you see negative 1 is much more simpler than 2 minus radical negative 1. Now I can simplify this because I have just negative 1. So this is basically 6 over negative 1, which is negative 6, and 3 radical 5 over negative 1, which is negative 3 radical 5. And that will be my answer. And last, I just want to talk about the roots of a quadratic function on graph. Like we said that if the discriminant of a quadratic function is a number greater than 1, then we'll have 2 roots. In this case, the graph of the function is going to look something like this. You see, this is a parabola, which is graph of a quadratic function. In this case, we have 2 roots. That means the graph is going to cross the x-axis at 2 points. So if the discriminant is greater than 0, the graph is going to look something like this, either here, here, or like maybe here. Anyway, it's just going to cross the x-axis at 2 points. If the discriminant is equal to 0, then the graph is going to be something like this. it's going to cross the x-axis at only one point, and that point is basically the vertex of this parabola. And if the discriminant is a number which is less than 0 or a negative number, then the graph is not going to cross the x-axis at all. So it's going to be, let's say, for example, somewhere like here. So it's not crossing the x-axis at all. That means we don't have any real solution, but we have two complex solutions. So in this case, we have one real solution, two real solutions, and this one, two complex solutions. So that's how the graph would look like in each case. And that was today's lesson. Have a great day. Bye. And this was today's lesson. I hope it was helpful for you, and have a great day. Bye.